Hello everyone, welcome to my YouTube channel TechTalk with Rais. Today's session is going to be very important and interesting with respect to distributed system design. So without wasting much time, let us jump into our today's topic, which is NGINX Plus, a multi-phase gateway layer Lulu. In this session, I'll try to cover a typical distributed system design. Particularly, I'll talk about gateway layer and I'll try to map different phases of NGINX Plus. Today's table of content is what is Lulu, typical distributed system design layers, API gateway layer, NGINX is a single body with multiple phases, and also we'll talk about NGINX and its different phases. From the topic you can see I am referring NGINX as a multi-phase gateway layer Lulu. So what is this Lulu? The English translation for the Lulu is something which is remarkable or wonderful. I personally feel that NGINX contribution at the gateway layer is too much and it's actually remarkable. This is why I am referring NGINX Plus as Lulu. We will try to learn typical distributed system design. Distributed system is a broad and complex topic. As the name suggests, distributed system has its own components distributed across the network. A good architected and distributed system can handle loads from a single user to millions of users depending on design factors and trade-off considerations. For a fine-tuned and good architected distributed system, it is always suggested to take layered approach for designing. Layered approach decouples system complexities and makes design topology simpler. For each layer, individual competency can be developed for development, configuration and maintenance. Layered architecture encourages design architects and dev to develop pluggable and API-oriented services and tools, thus maximizing possibilities of its utilization and consumption. Also, a layered approach minimizes impacts of topology changes on revisions. For a distributed system, everything is trade-off, which means one will be benefited at the cost of losing something. System design can vary with business and skill requirements. 3-tier and 4-tier application architecture are the best examples of layered approach of the system design. Okay, let's move on. In this slide, I am showing you pictorial representation of typical distributed system layers. This entire system has two parties. One is client side party, another is server side party. At the client side there is one layer, that is client layer. At the server side there are 4 layers: API gateway layer, application layer, caching layer and storage layer. At the client side, the requests are initiated from the client side and these requests go to the backend server via API gateway, and these the data is fetched from the actual storage and it is then returned back to the client. So this is overall pictorial representation of distributed system layers, different layers. Let's talk little more about each layer. At the servers, at the client side there's one layer, that is client layer. There are only two entities. One is user, or there's forward proxy. User can send request directly to the server side entities, or it can go via forward proxy. So forward proxy is kind of a tool or kind of engine or a mechanism where all the requests are routed through a reverse forward proxy. So the external world will know only the forward proxy IPs or forward proxy interfaces. In this way, these local users are masked. Basically, this way it provides additional enhanced security to the local client users, and this forward proxy acts as a security mask at the client side. Now the user request comes to the API gateway layer. API gateway layer acts as an entry point to the distributed system. This is an entry point. All the kind of authentication, authorization, load balancing, reverse proxy, all SSL termination, all these activities are handled at this layer. The request is routed via load balancer or reverse proxy to particular service which is responsible for the request. If the service request is of some read type, then it will go to some read service cluster, or if it is write type service or post type service, then it will definitely go to some other services. These services can be combined or segregated based on the implementation in the application layer. Finally, let's assume this request is for the write service, and our system is designed in a way that it is the request will come to write service, then write service will write those data, let's say, to the backend storage. We are using intermediate caching layer, which in this particular case, in this pictorial representation, this is a write through cache. That means whatever the data is being written in through the request, it will go through the cache, it will write to the cache, set up the cache, it will write that data in the cache, and the expired time will be updated in the cache against that data, and then it will again go and save or write to the master of the DB. Let's say when read request comes, first of all it will go and check in the caching layer whether this particular data is available in the caching layer. If it is available, the request will be served from the caching layer itself directly. But if it is not available here, that means a cache miss had happened, then it will go and seek for the data from the read replicas. This is how the entire workflow works. So these 4 layers of the server side entities are very important. At a very high level, if you see them, then you can see by segregating them in terms of layers or tiers how much the complexity is reduced. Storage layer is completely aside, caching layer is completely decoupled, application layer is also completely decoupled, and API gateway layer is also completely decoupled. So at a very high level, at each and every layer, individual tools, individual services, individual languages can come, individual competency can be developed for individual layers. There's no need for developers to know everything, right? So from this distributed system design, you can see that layering helps reducing complexity of the system, and topology becomes quite simpler, as explained in the previous slide. In this presentation, our area of interest is this particular layer. We are not going to talk more on other layers, although those layers are very important for this from the distributed system perspective. All the layers should be covered, but in this particular tech talk, our area of interest is this particular layer. So in this tech talk, we'll talk little more about API gateway layer only. Summarize all different layers of the distributed system from the previous slide. We can see there are 2 parties. One is client side party, another is server side party. At the client side, there is forward proxy, which also acts as a client side security mask. At the server side, there are 4 layers: API gateway layer, application layer, caching layer, and storage layer. At the API gateway layer, there are 4 major functionalities are available: API gateway and security control, load balancer, reverse proxy, which also acts as a server side security mask, and content caching. Application layer, which has different service replicas to handle more loads. Then caching layer to cache the data temporarily, and then finally there is storage layer to store data persistently, and thus it can be a database or some remote storage. So let us move on. Let's talk little more about API gateway layer. API gateway layer is one of the most important and very critical layer in distributed system design. It can play a vital role in distributed system design. Many functionalities an API gateway layer can provide. Some of the important functionalities are listed in this slide. Number one, API gateway and security control. An API gateway layer can act as API gateway. API gateway is an entry point to distributed system. All traffics are routed to the backend servers and services via API gateway. This acts as a superset of reverse proxy. API gateway has many important roles to play: SSL termination, access control, basic authentication and authorization, JWT token based authentication, API rate limiting, response caching, data throttling are key features an API gateway provides. API gateway layer can act as load balancer. With the increased load on the distributed system, load balancers efficiently distributes traffic to homogeneously configured backend servers. Several techniques and algorithms are used to route traffic efficiently. Round robin, least connections, random least time are some of the notable algorithms which are used to route traffic to backend servers. Homogeneous backend servers or services are clustered, and a VIP is used for request handling. An API gateway layer can act as a reverse proxy. This is a very important component in API gateway layer. This acts as a server-side security mask and stops internal backend service IPs from getting exposed to external network, and thus protects backend servers with enhanced security layer. This component is a subset of API gateway layer. All client interacts with distributed system through reverse proxy. Thus, they know only reverse proxy interface. Reverse requests are passed and directed to appropriate backend servers or services, and it collects responses from different services and servers and combines them and returns back to the client. An API gateway can also act as a content delivery network for content caching. Content delivery networks are proxies which sits at a geographically distributed gateway layer close to the user, and they have ability to store large static and dynamic contents. User requests for large contents are served to the user from the closest location to the user. System doesn't need to engage backend servers for user request handling. CDNs are two types: push CDNs and pull CDNs. An API gateway layer can also act as a high availability tool or HA tool. Distributed system uptime or availability is measured in terms of nines. 3 nines or 4 nines terms are notably used to describe system overall availability. 3 nines stand for 99.9% of system availability. 4 nines stands for 99.99% system availability. For better availability, HA is configured at the API gateway layer. Usually a pair of edge nodes are deployed at the API gateway layer and acts in active or active passive configuration to serve user requests and promise high availability. API gateway layer can also be used or helpful in system monitoring. API gateway layer also provides monitoring and health checks for backend servers. Several API label monitoring can also be provided in this layer. API gateway layer monitoring engine continuously sends health check packets to backend servers and updates their continuous health. Any sick backend node or service is reported and automatically removed from the list of serving backend servers and services. These all are important functionalities or features which an API gateway layer can provide. So let us move on. In this slide we'll talk more about NGINX. So from this diagram, I have created this diagram to explain the different functionalities of the NGINX. We'll try to expose, or we'll try to explain little bit about all the functionalities NGINX can provide. I have created this pictorial representation of all the functionalities the NGINX can provide. From this pictorial representation, you can see NGINX can play a role of load balancer. It can play a role of reverse proxy. It can play a role of security controller. It can play a role of API gateway. It can play a role of monitoring engine. It can play a role of content cache. It can play a role of high availability tool. It can also play a role of mail proxy. It all those functionality are provided by single body. Thus you can say that it has multiple faces which can provide multiple functionality with a single body, and it has multiple faces. This NGINX can work as an individual entity as a functionality. So it can be configured completely as a load balancer. It can be configured completely as a reverse proxy. It can be configured completely as a content cache or content delivery networks. So overall, if you see from here, it is just single body, but it can provide multiple faces or multiple functionalities. To summarize different phases of this NGINX, it can play different roles, like NGINX is a load balancer, NGINX is a reverse proxy, NGINX is a content cache, NGINX is a web server, NGINX is a HA tool, NGINX is a mail proxy, NGINX is a security controller, NGINX is a monitoring tool. These are the phases of different phases of the single body NGINX. So from these two slides you can see that NGINX is a very powerful tool which provides lot of individual functionalities and which is very important in the distributed system. So if I ask you to recall slide number 6, slide number 8, 9 and 10. So from slide number 8 and 9, you'll get to know that load balancing, reverse proxy, API gateway and security controller, high availability, content cache or security monitoring, or these functionalities are functionalities of API gateway layer, isn't it? Yes, it is API gateway layer features, and these are very important and critical features what API gateway layer provides. At the same time, if I ask you to recall slide number 10 and ask you which all features, which all faces NGINX body provides, then you will say that NGINX can act as a load balancer, it can act as a reverse proxy, it can act as a content cache, it can act as a web server, it can act as a high availability tool, it can act as a security controller, it can act as a monitoring tool, isn't it? So do you see any similarity between these two, like API gateway layer functionalities versus NGINX functionalities? One similarity what I see is basically whatever functionalities are required, critical functionalities are required at API gateway layer, all those functionalities are available in terms of phases in NGINX. That means NGINX can be configured individually as those tools to provide individual features or functionalities of API gateway layer. So if I put all those things in the slide number 6, so it will be like this diagram, where you can see from here that at the API gateway layer, whatever all the functionalities were there, like API gateway, load balancer, reverse proxy, HA, security controller, etc., etc., all those functionalities NGINX can provide. This single body can provide all those functionalities. That means this is a gem of API gateway layer, and this is why in the very beginning I told you that This is multi-phase gateway layer Lulu, that at this API gateway layer, this is playing a role of Lulu. It is wonderful and it is remarkable. The contribution towards the API gateway layer is remarkable, and this is why I am calling it Lulu. Thus, I prove that NGINX is multi-phase gateway layer Lulu. So thank you everyone for attending this tech talk. In case you like this video or this is helpful, please like and subscribe my channel. This helps a lot. Thank you so much.